Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So students, we are starting this session from where we stopped in the previous session. In the previous session, we had seen what is transpose and properties of transpose of class 12, chapter 3 matrices. So in today's class, we'll be going on to the next topic, which is symmetric and skew symmetric matrix. So what is a symmetric matrix? So this symmetric and skew symmetric matrices we had discussed in the types of matrices, correct? So there are different types of matrix: column, row, square, rectangular, diagonal, scalar, identity, as well as symmetric and skew symmetric matrix. How do we identify them, students? So if the principal diagonal is the line of mirror. Okay, principal diagonal is considered as the line of mirror, and other elements are called as, or other elements are mirror images of each other. Okay, if they are mirror images of each other with the same sign, then it is called as a symmetric matrix. If they are mirror images of each other with the opposite sign, then they are called as skew symmetric matrix. What is the condition to identify symmetric matrix? If A transpose is equal to A, that type of matrix is called as what? Symmetric matrix. What is skew symmetric matrix, students? Very similar. If A transpose is equal to minus of A, then it is called as a skew symmetric matrix. Understood? So now what we are going to see in today's session is, if there is any given matrix, so let us consider a matrix B is given, okay, of order m cross n. If we have to convert this matrix B into symmetric and skew symmetric matrix, how do we convert it? So that is by using a formula again. So what is the formula given by? The formula is given by P is equal to 1 by 2 of B plus B dash. This is symmetric matrix. So symmetric, remember students, plus. For skew symmetric matrix, what is the formula is? Q is equal to 1 by 2 of B minus B dash. This is what? A skew symmetric matrix. What are we doing here, students? A matrix B is given, right? This is given matrix. This, if you have to convert into symmetric matrix, operate it like this. Operate the matrix B in this form, and whatever resultant you are getting here, P, okay, that will be what? That will be a symmetric matrix. Understanding? Same thing here. If the given matrix B of order m cross n, if you have to convert that into a skew symmetric matrix, okay, so then you have to operate it in this way. The only difference is here it is plus, here it is minus, and the resultant Q is called as what? A skew symmetric matrix. As simple as that. So we'll have a quick look at an example. You will understand this better. So students, what to be remembered? What is very important here? Point 1, point 2, point 3, point 4. 4 important points related to symmetric and skew symmetric matrix. Okay. So we'll take one example. We'll see. Okay. So the next slide. We have an example here. Express the matrix B. So this is the given matrix now of order 3 cross 3, a square matrix, as the sum of symmetric and skew symmetric matrix. So directly now, students, we'll start with symmetric now. Okay, symmetric matrix. What is the condition to be satisfied? The condition to be satisfied is P dash is equal to P. And what is P, students? Let P be a symmetric matrix. Now P to be a symmetric matrix, what matrix is given to us? B is given. So B plus B called as transpose of a matrix. So B to the power of T or B to the power of 1 or B dash. Okay, this is called as what? Transpose of a matrix. Now we'll find out this. Okay, what is B dash? So what is transpose again? B dash is nothing but transpose of B. What is transpose? Writing the rows as columns. So what is the first row here? 2 minus 2 and minus 4. 2 minus 2 minus 4. Write it as a column. Next, minus 1, 3, 4. Minus 1, 3, 4. 1 minus 2 minus 3. 1 minus 2 minus 3. What is the order here? 3 cross 3. Same thing. Writing the rows as columns. Now we have to express this as what, students? Symmetric matrix, right? So we'll start expressing that in form of symmetric matrix. Now add these both matrices, B plus B dash. So what is B? B is already here, correct? B plus B dash. What is the operation between two matrices, students? Addition. And how do we add? Yeah, that is right. We have to add the corresponding elements of two matrices. So that will give us the sum of the matrix. Okay. So corresponding elements of two matrices, 2 plus 2 is 4. Minus 2 minus 1 minus 3. Minus 4 plus 1 minus 3 again. Minus 1 minus 2 minus 3. 3, 3, 6. 4 minus 2, 2. 1 minus 4 minus 3. Minus 2 plus 4. Minus 2 plus 4 is plus 2. Minus 3 minus 3 minus 6. So this is our B dash. Okay. Now we have to do what? Multiply it with a scalar 1 by 2. So here we'll write half of B plus B dash. So this will be equal to, multiply half to each and every entry of this matrix. So 4 into 1 by 2. So this will become minus 3 by 2. This will also become minus 3 by 2. Minus 3 by 2. 3, 1. Minus 3 by 2. 1 and minus 3. Now check the students. Okay, how do we check it? That condition must be satisfied, right? What is that condition? For symmetric matrix, what is the condition? P dash must be equal to P. If this condition is getting satisfied, then we can call P as what? A symmetric matrix. What did we get here, students? So this is nothing but equal to P, correct? Half of B plus B dash. So here if you see, it is nothing but equal to P. So this is equal to P. Now what is our P dash? Writing the rows as columns again. 2 minus 3 by 2 minus 3 by 2. Minus 3 by 2, 3, 1. Minus 3 by 2, 1 and minus 3. Now check whether P dash is equal to P. 2 minus 3 by 2 minus 3 by 2. Minus 3 by 2, 3 and 1. Minus 3 by 2, 1 and minus 3. Therefore we can write P dash is equal to P. Therefore P is a symmetric matrix. Understood? So P is a symmetric matrix. So students, two things very important. One is the formula and one more is the condition. Okay, moving on to the next one. So what is the next one here? Symmetric matrix we have done, right? So skew symmetric matrix we have to do next. Okay, we'll start with that. So we'll write matrix B again here. 2 minus 2 minus 4 minus 1, 3, 4. 1 minus 2 and minus 3. Okay. So 2 minus 2 minus 4. 1, 3, 4. Minus 1, 3, 4. 1 minus 2 minus 3. Minus 1, 3, 4. 1 minus 2 minus 3. Checking that once again. Yeah, everything is right. So this is our given matrix B. B dash, transpose of this matrix. 2 minus 2 minus 4. Minus 1, 3, 4. 1 minus 2 minus 3. Now B minus B dash. Why are we doing minus here, students? Because we are trying to express it as a skew symmetric matrix. And what is the formula here? So formula we'll write down here. Q, let Q be what? A skew symmetric matrix. Half of B minus B dash. So B minus B dash we're carrying out here, right? Okay, so what is B minus B dash, students? Subtract. Again, how do we subtract between the matrices? Corresponding elements must be subtracted. Okay. So now 2 minus 2 is 0. 2 minus of minus 1. So that is 1 again. Minus 1. Okay. Correct. Minus 2. Minus of minus 1. It will be minus 1. Minus 4. Minus 1. Minus 5. So minus 1. Minus 2 is 1. 3 minus 3 0. 4 minus of minus 2 is 6. 1 minus of minus 4 is 5. Minus 2 minus 4 is minus 6. Minus 3 minus of minus 3 is 0 as well. So this is what our difference between the matrices. Now what we have to do here? We have to multiply with scalar 1 by 2 and check whether the condition is satisfying or not. If it is satisfying, then Q is what? A skew symmetric matrix. Multiply the scalar, students, 1 by 2. Okay, we'll change the color here. So now 1 by 2 of B minus B dash. This is equal to what? Q. So multiply 1 by 2 each and every entry of this matrix. So we'll be getting 0 minus 1 by 2 minus minus 5 by 2, 1 by 2, 0, 3, 5 by 2, minus 3 and 0. So this is our what, students? This is our skew symmetric matrix. To check what is the condition, the condition is given like this, right? The condition is given as q dash is equal to minus of q. Let us find out what is q dash. So this is q, students, correct? This is q. What is q dash? Q dash will be 0 minus 1 by 2 minus 5 by 2, 1 by 2, 0, 3, 5 by 2, minus 3 and 0. Is q dash is equal to minus of q? So minus into minus is becoming plus. Minus of minus 5 by 2 is plus again. Minus as it is minus 3. Minus 5 by 2 minus 3. So therefore what can we write? Q dash is equal to minus of q. Now if q dash is equal to minus of q, then what is q called as? Yes, that is correct. Q is a skew symmetric matrix. Understanding, students. So this was our next topic, symmetric and skew symmetric matrix. So symmetric matrix and skew symmetric matrix both have conditions to be satisfied to be named as symmetric and skew symmetric or called as symmetric and skew symmetric matrix, and also the formulas are there which is used to express the given matrix in terms of symmetric and skew symmetric matrix. I hope this is clear. Any doubts regarding this topic? Okay, kindly let us know or let me know by commenting in the comment section. Okay, moving on to the next one. Our next topic, so that is elementary operations. So we have seen what are operations on matrices. So what were the operations on matrices, students? That is addition, subtraction, multiplication, scalar multiplication. So these were the operations on matrices. Here what do we have? Elementary operations, which means column or row operations. So we'll see what is elementary operations. All right. The interchange of any two rows or columns. This is what? Elementary operation related to rows and columns. How do you represent this, students? How do you represent this? R1 is interchanged with R3. Okay, next. The multiplication of the elements of any row or column by a non-zero number. How do you express this, students? This is expressed as R2 equals R2 by 3. R2 by 3 means row 2, the whole of row 2 is divided by 3. Okay, next. The addition to the elements of any row or column, the corresponding elements of any other row or column multiplied with a non-zero number. So how do you represent this basically? So this is represented as R1 is equal to R1 plus or minus 2R2. Just an example, students. Now why are we learning this elementary operations? I'll tell you why. See, students, elementary operations are used to find out the inverse of a matrix. Now to find out inverse of a matrix, there are two methods. One is by this elementary operations and another one is by using the formula. Okay, so in your exams, both can be asked, either from formula or from elementary row operations. So to understand by using elementary row operations and getting the inverse of matrix A, so these are the different types of row operations. So see the very first one, interchanging the columns or rows. So I have written with respect to rows here. So it can also be columns. So C1 interchanged with C3 or C2 interchanged with C1 respectively. Okay. So first one is what? Interchanging of rows and columns. What is the second one? Scalar multiplication of the elements. Okay. So R2 by 3, or sometimes we can write R2 is equal to 5R3. Okay. 5R2. 5 is being multiplied to each and every element of the row 2. 3 is being divided with each and every element of row 2. Okay, so multiplication, scalar multiplication. And the third one is like this. Addition to the elements of any row or column, the corresponding elements of any other row or column multiplied with a non-zero number. So see, this is a non-zero number. It could be plus or minus. So these are the three basic types of row operations which we have, or elementary operations which we have. So to implement this in a problem, okay, we'll take one example. Okay, try to understand that. So here we are taking an example. The example is telling using elementary operations find out the inverse of the matrix, and the matrix is given as A is equal to 1, 2, 2 and minus 1. So students, before we start with this, okay, so I would will have a very quick revision of this. So what is the meaning of multiplicative identity? Multiplicative identity means what? Students, multiplicative identity is a number. Okay, multiplicative identity is a number. Any number multiplied with that. So let us take 3. 3 into 1 is equal to how much? 3. Take 3 to the power of 10 into 1 is equal to how much? 3 to the power of 10. Means no matter how big or how small the number is, if you multiply that with 1, you will be getting the same number as the product. So therefore, what do we call? We call this one as multiplicative identity. Okay, so this is a number, students, but what are we studying right now? We are studying matrices. So in matrix, what is a multiplicative identity? Yes, that is right. Identity matrix is called as multiplicative identity in matrix. So for example, if there is a matrix A of order m cross n, if this is multiplied with an identity matrix of the same order m cross n, what will be the outcome, students? What will be the resultant here? Here the resultant would be matrix A of order m cross n. Understand? So here identity matrix is nothing but what? Identity matrix is nothing but a multiplicative identity. Understanding? So identity matrix is nothing but multiplicative identity. Now, but how do we find out inverse here? Okay, so that is what we are going to work out, and I'll also let you know how are we getting the inverse of it. Now let us start with the problem here. We'll change the color. So this was just an introduction. Multiplicative identity in numbers, multiplicative identity in matrix. Alright, now we'll start with the problem. So we will start the problem like this. So from here we'll start. So starting the problem, students, we'll write A is equal to I A. This is very similar to what? 3 is equal to 1 into 3. Correct? 1 is what? Multiplicative identity. Okay. Now, A will write as it is. What is A here? A here is nothing but 1, 2, 2 minus 1. Okay, 1 second. Which is equal to I as it is again 1, 0, 0, 1. And A will write it as A only. I'll tell you why. Later on, you'll understand. Okay. Now students, it is very simple now. Understand, how do we find out multiplicative inverse? Inverse of a matrix by using elementary operations. You see, we have two sides here, left hand side and right hand side. And on the right hand side, we have what? Identity matrix. Now your goal is to get that identity matrix to the left hand side. That's all. If you do that, okay, if you achieve that goal, your inverse will be ready automatically. So, but how do we get the identity matrix on the left hand side? How do we get that? So identity matrix is on this side, right? On the right hand side, we have identity matrix. You have to get it on the left hand side. How do you get it? By elementary operations only you have to get it. Okay. So what is the very first operation, students? See, this matrix must come here. That's all. Use elementary operations. If you do that, you will be finding out A inverse very easily. Okay, only one step. So students, now see, this element is already matching. 1, 1 is matching. What we'll do next is we'll make this 0. So if this is 0, 1, 0, 1, 0. What I said, you have to get the identity matrix to the left hand side. If that is done successfully, okay, one more step, you'll be finding out A inverse. So how do we make this as 0 now, students? Okay, we'll be using elementary operations here. We will write R2 equals R2 minus 2 times R1. Why 2 times R1 there, students? So see here, what is R2? 2 minus 2 times. What is R1? 1. What is 2 minus 2? 0. That is why 2 times R1. Understanding? So we'll write the matrix now. This elementary operation, whatever you have written, this is applicable to both this side as well as this side. So apply it to both the sides. Let us apply on the first side. So students, how do you write the C? Write down the brackets like this. And A also as it is. Now remember here students, you are only operating R2, right? Which means R1 is untouched. So there is no changes in R1. Right throughout R1. Okay, as it is. So 1, 2, 1, 0. R1 is untouched. So we have written R1 as it is. Now 2 minus 2, right? Minus 5. Same thing is applicable here. R2 is 0 minus 2 times of 1. So that will become how much, students? Minus 2. Correct? R2 is 1 minus 2 times of 0. So this will remain as it is, 1. Now see students. Okay, concept is done. So these both are done. We have to get 0 here next and we have to get 1 here. So if you are successful in doing that, then matrix inverse of matrix A is done. Okay. So on this side we'll write again. So next, what is our aim? We will make this as 1. How do we make this as 1 now? Or sorry, it should not be 1, it should be 0, correct? So see, 0 we have 1 0 1 0. So this must be 0 now, students. Okay, this must be 0. How do we make it as 0? We'll write row operation again. So this is in first row, right? So we'll write R1 equals R1 minus R1 minus, or we'll write plus here, R1 plus 2 by 5. 2 by 5 R2. How did I come up with this? Okay, that is one small question out of how did I come up with this row operation? So students, that depends upon the question. So since the question or since the given matrix is like this, that is why I have come up with that particular row operation. But how do we know that? Students, very simple. See the objective here. You have to make this 0. Do anything. Okay. So what do we have here? 2, right? So we'll change the color here again. What do we have here? 2. So R1 is nothing but 2 plus 2 by 5. We'll write it as it is. 2 by 5. Okay. Now what is R2, students? See here. What is R2 is minus 5. So write minus 5. So this 5 and this 5 will get cancelled. It will be 2 minus 2. What is 2 minus 2? 0. So which is equal to 0. So I got 0 here, right? So if you want anything, you can use any combination of row transformations. But objective is very simple. You have to get the identity matrix on the left hand side. Use how many ever row transformations you want. So this is the correct row transformation. Now we will write the matrix. So here again we are operating only R1, which means R2 is untouched. So write down R2 as it is. So this is 0 and minus 5, which is equal to minus 2 and 1 of A. Now R1 is equal to R1 plus 2 by 5 R2. What is R1, students? 1 plus 2 by 5 of R2 is 0. So 1 plus 0 is 1 only. Okay, next. 2 plus 2 by 5 of minus 5, that is becoming 0. Okay, this we have to operate now. 1, so here we'll write 1 plus 2 by 5 of minus 2. What is this equal to, students? 1 minus 4 by 5. 1 minus 4 by 5 is nothing but 1 by 5. 1 minus 4 by 5 is nothing but what? 1 by 5. Next, this one, students, R1, 0 plus 2 by 5 of R2 is nothing but how much? 1 again. So this is becoming 2 by 5 as it is. Now students, see on the left hand side we got 1 0 0. What should we get here? Plus 1. Correct. So how do we get plus 1 now? It is in R2, right? So write R2 is equal to R2 by minus 5. Correct. If you divide the R2 by minus 5, what will you get? You will be getting plus 5. So we will write the matrix now again. The matrix is written like this. 1 0 0 1 is equal to 1. First row is untouched, so 1 by 5 and 2 by 5 as it is. So this will become 2 by 5 minus 2 minus 5 minus minus cancel 2 by 5, and this will become 1 by 5, and this A is as it is. Students, we started from here. Correct. What is this? Given matrix. What did we transfer the given matrix into? The given matrix was transformed into an identity matrix. See, identity matrix of order 2 cross 2. How did we transform it? By using the row transformations. So I'll just highlight them. These are the row transformations. Number 1, number 2, number 3. So by using these row transformations, what would we do? We transform this matrix into identity matrix. So once this is done, how do we proceed from here? Okay, now students, see this. On the right hand side, so we will just write whatever the result we got here, we'll just write that as it is here. So here we got 1 0 0 1, which is equal to 1 by 5, 2 by 5, 2 by 5 and 1 by 5. Correct? 1 by 5, 2 by 5, 2 by 5 and 1 by 5 of A. We'll rewrite this again, students. This is nothing but I, which is equal to this matrix 1 by 5, 2 by 5, 2 by 5, 1 by 5 of A. Send this A on that side. What will happen? If you send this A on that side, what will happen? A inverse into I is equal to 1 by 5, 2 by 5, 2 by 5, 1 by 5. So A inverse into I, A inverse means what? So this was our A, right? Now A inverse is nothing but 1 by 3. So 1 by 3 into 1 is equal to how much? 1 by 3 only. So A inverse into I is nothing but A inverse only, students. Correct? Understand? Basic. So A inverse is equal to how much? 1 by 5, 2 by 5, 2 by 5 and 1 by 5. So here again you can take 1 by 5 outside. So finally the answer can be written like this. So A inverse equals 1 by 5 if you take it outside as a scalar multiplication, 1 2 2 1. So this will be our A inverse. I'll once again summarize this whole problem. There will be a given matrix A. Okay. So how do you write that? You will write it in this way. Only objective, get the identity matrix on the left hand side. So for that, use the particular row transformations. Once that is done, you'll be stopping at this point. You'll be getting the identity matrix on this side. Okay, then take A on that side. So A inverse into I is equal to A inverse, and whatever matrix is here, this is our A inverse. I hope you have understood this, students. Any doubts in this matrix? Finding out the inverse of a matrix, you can just let us know by commenting in the comment section. So I think that is all for today. I'll be seeing you in the next session with the next topic of matrices. Until then, take care. Thank you. Share and subscribe.